Good morning, everyone. Today I'm going to tell you a story about Datomic and its great composable queries. My name's Elizabeth Engelman. You can find me on Twitter and Instagram at ebethme and on GitHub at Elizabeth Engelman. I'm a software crafter at a consultancy called Eighth Light based in Chicago, and I'm really excited to be here. Here's a table of contents for today's story. First, we're going to take a look at an overview of Datomic. Then we're going to look at some example data and how we would implement it in Datomic. And then we'll throw a wrench into our system to see how to cope with the pressures. And then I'll share a couple of other things I've learned while working with Datomic in a production system. When I first gave a talk about Datomic, it was about a year ago this time at an internal Eighth Light mini conference. I was really excited to share with my coworkers what I had learned about Datomic on my client site. But I had also just adopted these 2 cats that I was really excited about as well. So it was inevitable for my feline friends to make their way into my presentation last year. And as it turns out, I can't help but think about cats when I think about Datomic, so you all are going to get the cat treatment as well. These 2 are about 7 years old and are brother and sister. They came with the names Nico and Hello, but I wanted to commemorate a new chapter in their lives by giving them new names. I've always loved animals since I was a kid, but I never got the opportunity to name a set of animals before. So their name choice was very important to me. And I ended up going with a few different options and trying them out. Even though it would be really cool if this conference was called Cats West, it's not, it's Closure West. So let's get some software in the mix so I don't spend my full time discussing cats. So let's suppose that I have a traditional relational database that I want to keep track of my pet data in. I would likely create a cat table with the name field. Then as I was changing their names every couple of weeks, I would go in and update the database with the name field, with that name. As I mentioned, they started off with the names Nico and Hello, and then I decided to try out the names Niles and Daphne after 2 characters from Frasier. However, if we'll notice with this system, I would be replacing their old names with the new names, and thus losing the record of their old temporary names. Actually, as I was working on these slides, doing some last-minute preparation, I was listening to the Beatles, and the song Rocky Raccoon came on, and I was reminded that I was going to name them Rocky and McGill, or Lil, but since those records were replaced, I lost that data. And that wouldn't have been the case with Datomic. Since it's always additive, I'm always going to be adding new facts to the database about my cats, never replacing the old ones. All data in Datomic is stored in what is called a datum, which is a 5-tuple that includes an entity, which represents something in the database. Here it's indicated by the entity ID, an attribute of that entity, the attribute's value, and then the transaction number when this datum or fact was added to the system. And then the last column is the operation, whether it was added or not. When I first entered these 2 in the database, I added 2 facts, one that says the entity of cat1 had an attribute of cat name of Nico, and the other one that says that entity 2 has an attribute of cat name of Hello. I can then add another set of facts when I changed their names to Niles and Daphne. And then since I had Datomic on the brain while I was naming them, I even considered changing the names to Rich and Hickey. But then it occurred to me that since they were brother and sister, perhaps naming them after a famous brother and sister duo would be best. And then it hit me to name them after Gina and Louise Belcher from Bob's Burgers. And as I thought about it, it seemed like these characters their personalities really fit the personalities of my cats. So Gina and Louise they are. And so let's add those 2 facts into the database as well. Since this database is always additive, I'm able to go back in time and query for what their names were as of transaction 1 on 2/15/2016 when I first got them. And then I would get the information that cat 1 is named Nico and cat 2 is named Hello. Or I can query as of the current database value, and the names would be Gina and Louise as expected. This immutability is probably one of the biggest differences between Datomic and all the other relational databases I've worked with. It's probably also one of my favorite things. But the implications of this immutability are really powerful. So let's dig into Datomic a little further to explore that. First, let's take a look at the architecture. Though this talk is going to focus on the composability of queries specifically, I'd like to note that Datomic is composable even in its architecture. It's comprised of 3 main pieces. First, the data store here on the bottom is unique in that it's external from the database system. This allows users to persist their data in anything from a SQL system, such as Postgres, to a NoSQL service, such as DynamoDB. The Datomic team reasoned that storing data is a problem that computing has already solved, so they focused on challenges like handling reads and writes. The peer, on the top left, is any application that includes the Datomic peer library. These peers have the ability to query data within the application itself, communicate with other elements in the system, and also represent a partial copy of the database through heavy caching. Because our application is able to query locally, each application instance has the ability to interact with the data set independently. And since the data is immutable, we can feel confident that querying it as of a certain period in time, we will always get the same results. The transactor, up on the top right, is separate from both of these components. Its sole responsibility is to write information into the database and then alert the peers of new facts that are added. It ensures that all transactions are ACID compliant. As I mentioned earlier, I got the opportunity to work with Datomic on a client project last year. The team I was on at this client worked on a multi-tenant application that would allow financial investment organizations to create a customized web portal for their customers. So these customers could view their account information, look at fund research, or documents. The main use case for Datomic on this project was a microservice that we called the visibility service. We would query this service and get a list of documents that a particular user was allowed to see. There were also a couple of important reasons for creating this visibility service. One is that the logic was previously in a series of SQL queries that was spread throughout the application over time, and so extracting this logic out into a microservice made a lot of sense. It also became clear that a graph database-like structure would be helpful for this kind of data, and so we were using Datomic as basically a graph database. Also, we were implementing a new customer who understood the visibility of documents differently than all previous customers. So the ability to use the same kind of data that we previously had, but in a different way, worked well with Datomic. Because Datomic is flexible in its structure, for this new customer, we could add attributes to the data without needing to backfill existing clients to make the database happy, which we'll see with our example schema in just a second. So let's explore this problem in a bit more depth with this simplified data set, with some more cats and some less client secrets involved. So let's pretend we have some software that animal shelters can use to keep track of their animals and also share information about animals on their website, depending on the permissioning of the user. We have two visibility groups. The public visibility group allows users to visit the website to see animals that are currently up for adoption, and then the employee visibility group is for the users to see animals that have just been taken in but aren't ready for adoption yet. So this would be for the employees. If we look at the public visibility group, they're in or have an association. If we look at the public user, they are in or have an association to the public visibility group. And by being a member of that group, we're able to see all of the animals associated to that group. But they will not be able to see animals associated to the employee visibility group. The employee users would be a member of both groups, and so they could see all the animals. Now we've had the stage set, let's make sure we can implement this default behavior in Datomic, taking care to leave our code open for changes in the future. Hint, there's going to be some changes. Oops, that made a lot of noise, sorry. We could probably talk about Datomic schema in depth for hours, which is a little out of scope for this talk, obviously. But I want to highlight a couple of things before we move on to discussing the database structure. Schema in Datomic describes and installs in the database the set of possible attributes that an entity can have. It does not, however, describe which entities can have which attributes, which we'll see in a second. For our example database, we'll have a user entity that has a type attribute, which we'll use for either the public or employee user. We'll have an animal entity that also has a type as well as a name. We'll probably would want to include more attributes onto these tables, but for now we'll just keep it at this for simplicity's sake. And then we'll have the group entity, which will have a name attribute as well, either public visibility group or the employee visibility group. And it will also have a group member attribute whose type is reference, which means that we'll be able to reference another entity in the database. Because Datomic's schema is flexible, this group member attribute could either be used to describe a user, which is how we're going to associate users with groups, or it could be used to describe an animal, which is how we're going to associate animals with groups. Now let's write our first query that will allow us to get from the user to the group and then to the cats. As we walk through this query the first time, let's pretend we're looking at a public user, so we're looking at the top branch. We use Datalog to query Datomic. Datalog is a logic-based query language which utilizes pattern matching. At the top of the file here, we're requiring Datomic's API, and then using its queue or query function here in the user to animals one function. Queue takes in our query clauses as a list, and then a database value, since we're querying the database as of a certain time. And finally, any parameters that we're passing to the query. The first clause here is saying to find an entity, which we're representing with the variable a, and this is what we're returning from the query. Next, we have the in clause. A variable that begins with a $sign here represents the database value, and it's idiomatic just to use a single $sign. This is also where we'll include the user type parameter. Lines 8 through 11 are our where clauses, which are written as data patterns. These data patterns are in the same format or order as our 5 pieces of the datum. In this example, we're only going to care about the first 3 pieces, so the entity, the attribute, and the value. And then we can leave the other 2 pieces out of the data pattern. So line 8 is asking for an entity represented by u that has an attribute user type with a value of the user type we're passing in. Line 9 is looking for an entity G with an attribute group member that has a value of the user that satisfies the predicate on a line above. Line 10 is looking for the same entity G that also has an attribute group member with the value of A. And finally, on line 11, we're saying that the entity A must have an attribute animal name. And you'll notice that we don't specifically include the value in this last data pattern, and that's because we don't necessarily care about the value of A in this particular query. It's also important to note here that for any variables that are in more than one data pattern, this acts as an implicit join. And if we run this function with our public user, we'll get back the black and white cat. There we go. And then if we run it with the employee user instead, we'll get back all 4 cats. It's also important to note that Datomic doesn't return pictures of cats. It's going to return the entity IDs, but I thought these were a little bit funner to look at. So this is the basic task of querying our data, but there's some refactoring that we can do because this particular query isn't really taking advantage of Datomic's composability. So here we've refactored the query operation to be composed of 2 query rules that are defined in the first 2 defs on line 17 and 22. Rules are little packages of reusable logic or algorithms that we can plug into our queries. We can even use several rules together in our query clauses to compose larger, more complicated queries. The def on line 17 is defining a rule that describes how to traverse the graph from the user type to the associated group. The first line in the rule is the rule head, which names this package of logic. And the other rule defines how to traverse the path from the group to their associated animals. We can plug this set of rules into our queue function, much the same way we're including our database value and parameters. The rule set is represented by the % in the in clause. Once we've passed the rule set into the queue function, we can then use any of the included rules in this query. And if we run these queries again with the public user, we should get the same results, the 2 cats. And now with the employee user, again, we get all 4 cats. Now that we've got our query in order and refactored it, let's put some further pressure on our system and our composability by adding a new special customer. For this customer, let's suppose that they also have this idea of hierarchical animal visibility, But they also want to be able to assign animals directly to users, the animals that aren't in two groups specifically. Maybe the use case for this is that animals that have been adopted, an employee is assigned to them so they could follow up with them later. So now we have two different clients with two different ideas of visibility. They'll each need different queries to represent those disparate concepts of visibility. They'll have different data sets, and we want to store it all in one database. These challenges put several pressures on our system. Our schema will need to change to incorporate this relationship from a user directly to an animal. We'll also need a mechanism to decide if the incoming user should get the default query or the special query, keeping in mind that our particular customer also wants the default behavior in addition to their special case. The schema changes necessary for our new customer would include introducing our new relationship between the user and the animal. We're also introducing the need to know if it's a specific user rather than just a user type. But as we've established previously, our schema is flexible. So we can add new attributes for the user email and the user assigned animal, and that's it. Since our schema doesn't describe which entities can or should have which attributes, there is no restriction in our database that will force us to go back to our previous data and backfill the assigned animal's attributes for users that are already in the system. We just won't add an assigned animal value to those users. And this means we don't have to make any changes to our existing customers. But it should be noted that since there is no database restriction here, we would have to be particularly mindful in our application code and make sure that we are never assigning an animal to a user for our normal customers. So let's look at the query. Here, instead of splitting the logic of getting from a user to an animal out into two smaller rules, as we had in the previous example, I'm just grouping them all back into one rule, defined from on lines 42 to 47, just to make this a bit simpler to read. This rule, called user to animal, behaves in the same way it did when it was in two separate rules. And here on the second rule, that's on line 49, this rule gets pretty interesting. This rule has the same rule head or same name as the rule above, but the definition is different. We now have a data pattern that is looking for entity U with a user email attribute that has a value of user email that will pass in. And then it checks that the entity U has an assigned animal attribute and assigns that value to A. So how does this work? If a rule has two definitions but the same rule name, this acts as an implicit OR. So here we're redefining how to traverse the graph from a user to an animal by adding another possible path to the mix. Okay, so now let's put the whole thing together. Our multi-method user-to-animal function at the very bottom will now dispatch which query function to call based on whether or not we're passing in the customer query parameter. When we're passing in the particular customer as our custom query, we'll dispatch to the special user-to-animal function. Otherwise, the default behavior is to use the normal user-to-animal function that we previously defined. Note on line 59, we're including both the default user-to-animal rule and the special user-to-animal rule, utilizing the implicit OR that these rules offer. And so let's run this function. And we'll get back just the black and white cat for a public user, the black and white cats. But when we run it for the employer user, we'll get back all 5 cats. We could actually refactor this a little bit more. Instead of having different query functions for the normal customer versus the particular customer, what if we just use the same function? And then our multi-method could just decide which rules to pass in based on the custom query parameter. So now that we've built our system and had to change it for our particular customer, I'll mention a few things of note that I learned while working with Datomic on a client site. One is that we should be mindful of the particular customer because there's always going to be another one. On my client project, we experienced something very similar to this scenario, and at some point realized that our query namespace, and even worse, the associated tests, had been overrun with mentions of the particular customer. It was no longer a generic query to find allowed paths from a user to the animal. The solution to this problem is probably quite obvious in hindsight. We just extracted out a specific namespace for our particular customers and kept a default namespace nice and generic. Speaking of tests, unit testing with Datomic is a pretty great tool in managing these particular customers, as well as developing composable queries. One thing we found really valuable with our unit testing is this nifty function in the Datomic API called with, which allows you to interact with any database value with any additional data you would like. So we're able to test our queries without ever having to transact test data into the actual database. The fact that we can include these different data models into one database is pretty powerful, but it also requires some additional planning and mindfulness. At my client, we began to build out a set of data for each use case, the normal path, and then the subsequent particular customers, with the intention of using it for regression tests. Since Datomic is a fairly new technology, our team was still learning new and better ways to do things all the time. And so it was really important to us to have a way to refactor confidently, and we hope that the regression tests would be a great tool for that. As we implemented new and different customers into our system, we learned a lot of new and different things about our system. One customer of my clients had lots of data to traverse in the graph, which taught us the lesson that though query order may not matter logically with Datalog, you'll get the same results whatever order you put it in, but performance, it really does matter. So we should put the most restrictive clause first, because we found that a function that took, or that a query that took, I don't know, a couple hours one way would take 24 hours before we refactored it, which was not okay. Okay, and so now to conclude, this idea of creating a multi-tenanted application or having one application with the possibility of multiple different existing data sources has been prevalent in my experience. My current client now is actually dealing with a similar issue. And this question of whether we're designing data in our systems based on how our database is currently set up, how our client's database is set up, how our third party's database is set up, or how the data should be structured is one that's come to mind a lot these days. Learning Datomic has helped me open up my mind to this problem and made me more aware that this is something that will continue to exist and we should consider as we're designing systems. Because there is so much flexibility in Datomic, we have more creativity to model our data in a way that is more efficient for us and makes the most sense for us, but also is most efficient and makes the most sense for our users. Thank you so much for your time today. If anyone really liked the cat pictures, Gina and Louise have their own Instagram at Adventures of Gina and Louise. Thank you.